Okay, we want to do the integration of this. So we're going to need to let u be something. We're going to let u be this denominator. That's pretty typical. So u will be 1 plus e to the 7x. And then du dx, the derivative of that, derivative of 1 is just 0, skip that. E to the 7x, he's our favorite one, does nothing, but then times 7 because of the chain rule, right? Right, when the inside is anything other than simple x, chain rule says multiply by the derivative of the inside, derivative of 7x is just 7. So then multiply both sides by dx. Boom. So du is, I'll put the 7 in the front, 7 e to the 7x dx. Okay, so let's take this derivative and let's see if we can start rewriting all the x stuff in terms of u stuff. So we have e to the 21x on the top. I'll just leave that be. The bottom, that's just u. And then we have dx. So, what can we do? Well, here's a trick. I'm going to rewrite that integral. What I'm doing, where my eye is going, is my eye is down here going, look, I have an e to the 7x, but that's e to the 21x. So I can say, look, I can make that e to the 14x, e to the 7x dx over u. Why? Because I want to replace, change the color, I want to replace this part right here with this right here. See that? So I can do that legally because these add. 14x and 7x goes back to 21x. You can, right, powers add. When you have the same bases multiplying, bases the bases are the same, they multiply, the powers add. Remember that rule from pre-calculus? So I think, oh, okay. So then if I come back over here and I multiply by 1/7 on both sides here, boom, that cancels out. I get 1/7 du is e to the 7x dx. So that means wherever we see e to the 7x dx, we can replace with 1/7 du. So this becomes 1/7 du. So this becomes, bring it down here, this becomes the integral of e to the 14x. That's still up there. And u still on the bottom. And then in the front now, we have 1/7 du. We're getting so close. Let's grab that 1/7, bring it to the front. But we still have, we got u here and u here, but we still got this guy. What can we do? We got to replace that e to the 14x. We can't do that. You might say, well, just use this again. No. That's got a dx. We can't be putting another dx or du or something like that in there. We've already got our du. We've changed from dx to du. That's done. You got to mess with something else. What else? This guy. Do you see it right there? Let me help with that. Grab this guy. Oops, wrong color. Grab this guy. Bring him over here for a second. That means so u is 1 plus e to the 7x, right? So if I subtract 1 from both sides, boom, boom, I'm going to get u minus 1 is e to the 7x. Now I need to make e to the 14x. What are you going to do? Square both sides. Second power, second power. Do you see that? That means e to the 14x, right? 2 multiplies 2 times 7x, 14x. And that's u minus 1 squared, which is what? That means u minus 1 times u minus 1. Are you tracking with me? So I can distribute that. That's u squared minus 1u, boom, boom, minus 1u plus 1, negative 1 times 1, is e to the 14x. That means u squared minus 2u plus 1 is e to the 14x. Oh. So I can replace, so that where we're at, we're with this integral here. We grab this integral and bring it down. We have integral of e to the 14x on the top. E to the 14x on the top, u on the bottom, and 1/7 du in the front. U on the bottom. I'll put the 1/7 in the front. Du. So now this e to the 14x e to the 14x is that. So this becomes the integral of, and what do I got? I've got, ooh, I'm in the wrong mode there. I've got u squared minus 2u plus 1 over u du with a 1/7 in the front. Are you tracking with me? We've made it into all u. This has been a road. Are you with me so far? So I let the u be the denominator, and then I did the derivative stuff, and I found e to the 7x dx is 1/7 of u. So I rewrote that 21x as 14x and 7x, replaced the e to the 7x dx with 1/7 of u right there, but then I still had this e to the 14x. I thought I can come back up here and get e to the 14x in terms of u. So I subtracted the 1 and then squared both sides. E to the 4 and then FOILed it out. E to the 14x is u squared minus 2u plus 1. So e to the 14x is u squared minus 2u plus 1 right there. Okay, now let's break it up over a common denominator. So now we'll say, oh, this is 1/7 integral of, and you can just make it three separate fractions, u squared over u minus 2u over u plus 1 over u du. Just three separate, right? You can do that. This is common denominator. And so we're getting close. This will be u. Two of these cancel here. Plus 1 over u du. See that? So did there, right? U squared, this canceled this, just left u. This canceled 2, this is just 1 over u. Now I can do the antiderivative. I can do that. So here we go. What's the antiderivative of that part? So it's 1/7. And I'll just put that in the front here. This is 1 power, so add 1, u squared, and put a half in the front. Minus, this can be 2u when we do the anti of him, because that's what the integral we're doing what the integral says right now. The integral says do the anti, the du do the anti. The operators are going to do their thing now. So what do? You add 1 to the power, u squared, divide by 2. This is 2u because derivative, this is minus 2u because derivative of minus 2u will go back to minus 2. And then what about that last part? What's the anti of 1 over u? It's the natural log of absolute value of u. Remember that? The derivative of natural log goes back to 1 over u, right? Okay. So let's put the 1/7 in the front and of our brackets here. And we're going to have 1/2. But now what is u? Let's go back to x. What was u way back in the beginning? U was 1 plus e to the 7x. 1 plus e to the 7x. Like that. Minus 2 times u, which is again 1 plus e 7x. Might need just a little more room here. Plus natural log of absolute value of 1 plus e to the 7x. There it is. That was quite an integral. So let's double check. Are we right? A half minus 2 natural log. So we get, I'm not seeing it. What is it? Where is it? They're going to need the 14x. Oh, did they multiply things out? Oh, yeah, I don't want to multiply things out. I'm sure they'll take it just like this. They must have done something a little fancier there when they did that. Yeah, I'm not gonna mess with that. I'm just gonna leave it be. So our answer's right, and there we go.